Okay, let's go ahead and go over the tables. Let's look at the named ranges. These are for the to bring values into the functions or the subroutines that we wrote. The first one is coefficient C. Basically, that's just this value here for C. See, coefficient C, it just gives it the value C, but it does so because it's a range. And it needs to be a range because, and it needs to be a value in a range because that was the code that was given in the Word doc or in the PDF, which I copied into helper, right? So when you do the get elements, it looks for a range, a value within a range. So as to not have to rewrite all of this, I left it the same way it was and just assigned the three atoms that we're looking for, carbon, hydrogen, and oxygen, to COEC, COEH, and coefficient O for oxygen. And these are used right here on this equation where it gets the element. So this is basically just passing this formula H, which is in this range, and then it goes through and counts the number of H's and divides by 2 because of the equation to find the balanced reactions. There's the balanced reaction equation for oxygen in terms of X based off of the instructions. There's a balanced equation formula for H2O in terms of Y, I believe. And then that's the balanced equation for CO2 in terms of Z. And then this is by default always going to be 1 on this the actual species that's there. So it puts the formula there. That's just a lookup to see which species it is. If it's nothing, then it just puts a blank there. See, right there's a blank if it's nothing. Um, Again, and then you helped me with these equations. So they are exactly as you defined them. Let's go back and look at some more variables. Formulas, name variable, formula list. Let's take a look at that. That is this right here, formula list. It's just simply this table so that you can take a formula and have it search through here and return a value based off of the VLOOKUP function. And we call that in the actual AFT function for HO check and for HIO. So this basically just runs it. Looks up my ISP, which is passed to the function, and that's going to be whatever value that's passed to it. When it's called, I'll show you that's over here. So there's HIO. On this one, that my ISP is going to be CO2, which is the species you're looking up the data from. And the first one returns what's in the third column. By the way, this first HO check, that was something that I ran so that I could see what the calculations were and test it if I knew what. So if you know what TAD is and you put TAD in there, you can run this and it'll check it and see if all of the numbers add up right. It creates this output field right here. If you don't know what it is, it's going to give you erroneous numbers here. But if you know the right answer, you can put them there. It'll tell you what these are, and you'll see that this and this balance to 0. Okay. What we did to find that, though, is the goal seek function, which basically just changes this number until this product sum and this product sum, when subtracted this from that, gets you 0 here, or within a precision of 0. So it'll have to be like a significantly close number. So right there, that one's negative 9.27 to the negative 0.5. That's extremely precise, but there's the answer. Okay, let's go back to the next name range. The is running, that's this here that lets it kick itself out. This is for automation, so that you don't have to click a button. It just checks and see if the formula is running, so it doesn't recursively call it infinitely. The next one is species list. That is this list here. That's just to create the drop down list that's right here under data validation. So like on this column, we just went to home, data, data validation. You see that it just equals a list, a drop down list of species list. That just gives you that first list. Then this one is species table, where it takes the list and returns, so whatever you select in the drop down list for species, it returns the formula right here. So you do VLOOKUP species table given whatever is selected here. And that's just copied from here. So again, this feeds, you select it here, this feeds this. This will have an error check once it goes to run and make sure that's 100%. If not, it errors out and you have to change it and then make a change somewhere else. Like, just click on that. If it doesn't run, it'll correct it and run. But it should automate. It may time out because error checking, you just got to like get it to run again by making a change. So automation works whenever a cell is changed, it runs that code. So if you don't change a cell, it won't run the code. So if you ever open it up and you're like, that answer's not right, it's because it hasn't been changed. It needs to recalculate. You just need to, double click on a cell, press enter, and it'll give you the right answer. Let's see, formula, what's next? We've got the TADS guess. That's your starting guess for TADS. We set that to 1,000. And then the final variable is T reference, which that by default in the building of the program set was supposed to be 25. That's the instructions that we were given. So then you need to go in here, these two modules. You have, when the program opens up, this workbook, when it opens, it checks to make sure that it's saved locally and the macros are enabled. If not, it gives you a message to enable it. And then it sets is running to false because it's obviously not running. This private sub is a workbook sheet change. Whenever the sheets change, it does an application calculate full, which does recalculation of all the formulas. And then if is running equals true, then it just exits the sub because it's running and changing things to get the goal seek to find the optimal number. Otherwise, it would keep calculating as it's trying to find, reiterating and creating an infinite loop where it's calling itself because it's changing itself to find the goal seek value, which is a change that causes it to call itself again. But it checks that if it's not running, if sheet name doesn't equal tables and sheet name doesn't equal cases, which are the two tables that we don't want calculations run on, then it calls the goal seek tab. So if it's is running as false and you're not on the tables or the cases sheet, then it runs the goal seek tab and it finds the optimal solution for it for TAD. So then we've got the actual AFT module, which includes the goal seek TAD sub that it calls, and then the H not check, which basically checks the values. Basically, it calculates whatever TAD is. So it needs a value for TAD, and it brings that value in when you call the function. So when you call this user-defined function, it's going to use this value of TAD, whatever it is. So that's where the goal seek thing will set that to 1,000 because that's what we have it set for in our tables. And then these will calculate all these numbers based off of that being 1,000. So it'll give you what all of these values are, with this being the TAD of whatever this 1,000, and it'll go from the reference temperature to the current TAD. Then it'll change the TAD and it'll recalculate until it gets this to go to 0. The next set of code we'll look at is the went over that. This one here is the HO. This calculates the H naught at time n, which is basically this function here, all of these functions here. So they're just tied to their corresponding species. It basically passes a string to it of what you're looking for, and it will figure out based off of the equations that it needs from the lookup table right there, from formula list, what A, B, C, and D, and then A naught. A naught is actually this whatever. Really, it should be called A degree or whatever, but I'm calling it A naught. It's whatever value is in this field, and it just does the math on it, integrates it, and gives you the solution. And place it right there. So let's check methanol here. We get 100% excess air. We'll make that 100 and blammo. There it is. That's it. Just those 3 simple routines, a couple of named ranges so that it has some way to look, and calling Excel functions, and then doing some math. That's all there is to it. So just let me know if you have any more questions or if something doesn't go right. Thank you.